Some of the most fascinating stories in space are not discoveries themselves, but the machines we send to make those discoveries possible. A space mission is basically a question with engines, antennas, sensors, and a long journey ahead of it. Sometimes the question is simple to say, what is this world made of? Is there ice beneath that surface? Can a spacecraft survive near the sun or land gently on another planet? The core question behind every mission is this: why send something into danger across millions or even billions of kilometers when telescopes on Earth can already see so much? The answer is proximity. From far away, a planet or moon is a point of light, a colored disk, or a faint signal. Up close, it becomes a place. A spacecraft can taste dust, measure magnetic fields, listen for radio whispers, map gravity, and watch how a world changes over time. What is known is that missions have transformed astronomy from distant observation into direct exploration. Robotic spacecraft have visited planets, moons, asteroids, comets, and the outer edges of the solar system. They have shown us storms larger than Earth worlds with hidden oceans and landscapes shaped by ice, lava, wind, and impacts. What is uncertain is always the most exciting part. Engineers can calculate a trajectory, build redundant systems, and test hardware on Earth. But space is not a laboratory. Radiation temperature, swings, dust fuel, limits, and tiny timing errors can change everything. That is why missions hold attention. They are not just announcements. They are unfolding stories, where careful planning meets a universe that does not have to cooperate. The memorable takeaway is simple. A mission is humanity extending one careful fingertip into the dark. That is why even a quiet spacecraft can feel like a turning point. And once that fingertip touches something new, the next question begins. What makes a space mission compelling is not only where it is going, it is the tension between a plan made on Earth and a place that has never been fully understood. Before launch, a mission sounds controlled. Engineers choose instruments, scientists choose questions. Teams practice commands, rehearse failures, and build paths through gravity. Every part has a purpose, but after launch, the mission belongs partly to space. This is where the known and the uncertain separate. What is known may include the destination, the main goals, the design of the spacecraft, and the kind of measurements it is built to make. A probe headed for a moon may study its surface, its gravity, its magnetic environment, or hints of material below the ice. A rover may examine rocks and chemistry. An orbiting telescope may collect faint light that never reaches human eyes clearly from the ground. What remains uncertain is what the spacecraft will actually find, how complete the data will be, and whether the environment will behave as expected. A landing site may be rougher than planned. Dust may cling to solar panels. A world may be quieter, stranger, wetter, drier, younger, or older than scientists predicted. That uncertainty is not a flaw. It is the point. Space missions are compelling because they turn prediction into evidence. Before a spacecraft arrives, scientists have models. Models are careful, useful, and grounded in data. But they are still maps drawn before the traveler reaches the landscape. When the mission begins returning measurements, the universe gets a vote. Sometimes the result confirms an idea. Sometimes it forces a better one. And sometimes the most important discovery is not the headline goal at all, but a strange signal, an unexpected texture or a pattern no one designed the mission to find. That is why mission stories last. They remind us that exploration is not a single moment. It is a conversation with reality, one signal at a time. The most useful way to understand any space mission is this. It is not a promise of a discovery. It is a disciplined attempt to let nature answer. That matters because space can tempt us into certainty too quickly. A destination may sound familiar. Mars the Moon, Jupiter's moons, an asteroid, a comet, the Sun. We give these places names, draw them in books, and turn them into symbols. But a mission reminds us that a named place is not the same as an understood place. The best missions begin with humility. Scientists may think a moon has an ocean beneath its ice. They may suspect an asteroid preserves ancient material from the birth of the solar system. They may expect a planet's atmosphere to reveal clues about climate chemistry or history. Those are not wild guesses. They are built from observations, physics, and previous missions. Still, the spacecraft has to go there and test the idea. The known part is the method: launch, travel, survive, measure, transmit, and let teams on Earth compare the data with what they expected. The uncertain part is the answer. Space may confirm the story. It may complicate it. It may reveal that the question was too small. That is the real value of missions. They do not just deliver facts, they improve our questions. A flyby can turn a dot into a world. An orbiter can turn a world into a system. A lander can turn a surface into a place with texture, temperature, and chemistry. Even a mission that struggles can teach engineers how to build the next one better. So the clearest takeaway is this: space. Exploration is not a straight line from mystery to certainty. It is a careful chain of attempts, each one reaching a little farther than the last. And the next briefing goes deeper into the question. Every mission leaves behind: what will we send next, and what are we brave enough to ask?